All right, here are the book review problems from Chapter 1 test. Okay, I'm working on starting with pages 29. I'm going to work numbers 1, 4, 14, 18, and 22. So number 1. Solve each inequality and graph. So I have negative 12 less than or equal to 24x. Okay, our base rule is we have to get the variable by itself. So divide each side by 24. So we're going to get negative 1/2 is greater than or equal to x. So it says graph the inequality. So we need a number line. I'm going to mark negative 1/2. It's reading from the variable over. It's x less than or equal to negative 1/2. So it's a solid circle because there's an equals, and it's less than, so it's to the left. Okay, number 4. I have 57 minus 4t is greater than or equal to 13. Okay, we got to isolate the variable by itself, so we're going to subtract 57 each side to start the process. So I'm going to have negative 4t is greater than or equal to negative 44. Now notice the negative sign. I'm going to divide each side by negative 4 to isolate the variable by itself. When I divide by a negative, I have to flip the inequality sign. So it's going to be 4 less than or equal to 11. I'm sorry, not 4t less than or equal to 11. So to graph that on a number bar, I'm going to mark 11, and it's a solid circle because there's an equals to, and it says t is less than, so it's going to go to the left. Okay, next one, number 14. The length of a picture frame, so I'm going to start writing this as I'm reading. The length of a picture frame is 3 inches greater than the width. So the length is the width plus 3. So the width we'll just put as W. The perimeter is less than 52 inches. Describe the dimensions. Alright, so we know the perimeter is less than 52 inches. So in terms of inches, the perimeter is less than 32. In terms of the variables, the perimeter is 2 times the width plus the length. So the perimeter would be 2 times 2w plus 3. Let's distribute that 2. So the perimeter would be 4w plus 6. So everybody see how we distributed the 2? Okay. So all we have to do now is, since those are both perimeters, just set the equations. 4w plus 6 has to be less than 52. So let's keep looking. We got to isolate the w by itself. So now I'm going to subtract 6 on each side. So I get 4w less than 46. Okay, divide each side by 4. There's no negative, so it's going to be w is less than 11.5. It was in terms of inches. Okay, so if w has to be less than 11.5, the dimensions would have to be less than, the width would be less than 11.5, and the length would be less than 11.5 plus 3, Or you could say the length is less than 14.5. So there are your dimensions. There's your width and there's your length. Okay, moving on. Number 18. Solve each compound inequality and graph the solution. So I have 2x greater than negative 10 and 9x less than 18. Divide each side by 2. X is greater than negative 5 and divide each side by 9. X is less than 2. So we're going to put that on a number chart. So I'm going to mark negative 5 and I'll mark positive 2. Okay, looking, it's x is greater than negative 5, so it's a hollow circle because it does not have an equality, and x is less than 2. Again, a hollow circle because there's no inequality. Because there's an and statement, they're going to be joined. So there's number 18. Last one on this page, number 22. Solve each compound inequality and graph the solution. 4x is less than 16, or 12x is greater than 144. Got to get the variable by itself, so on the left side we'll divide by 4. So we're going to get x is less than 4, or divide by 12, getting the variable by itself. We're going to get x is greater than 12. So we're going to mark 4 on our number line and 12. And x is less than, so less than is going to the left, and 4, and it's a hollow circle on 4 because there's no equality sign, there's no equal sign. 12 is greater than, or x is greater than 12. So there's your examples from section 1.4. Okay, moving on to the next section. Here we go. Now we are doing section 1.5. And we're doing numbers on page 36. Numbers 4, 7, 10, 13, 16, 19, 28, 31, 34, 40, 44, and 46. So starting with number 4. 2 absolute value signs, 3x minus 2 is equal to 14. Okay, remember we're treating absolute value signs as equalities, as parentheses, so we don't want to mess with them. We want to keep them isolated. We got to get the absolute value sign isolated on one side of the equation. So we treat it like parentheses, so we'll divide each side by 2. So we get the absolute value of 3x minus 2 is equal to 7. Since we have the absolute value sign by itself, isolated, we now can go to the next step and set 2 equations. We can set a positive equation and a negative equation. So here we go. 3x minus 2 is equal to 7. There's my positive equation. 3x minus 2 is equal to negative 7. That's my negative equation. So now it's going to be an OR statement with these. For absolute values, you can have 2 answers. So let's get to work. On the left side with the positive, we'll add 2 to each side. So I'm going to get 3x equals 9. Divide each side by 3. we're going to get x equals 3. Don't forget our or statement. So now we're going to work the negative side. Add 2 to each side of the equation. I'm going to get 3x equals negative 5. Divide each side by 3. So I'm going to get x equals negative 5/3. Number 7. Absolute value of x plus 4 plus 3 equals 17. First step, we have to get the absolute value isolated by itself. So we're going to subtract 3 to each side. So now I have the absolute value of x plus 4 is equal to 14. So now I can have a positive solution and a negative solution. So we'll write the positive one. X plus 4 equals 14. And the negative one would be x plus 4 equals negative 14. So we're going to subtract 4 on the left side. So we're going to easily get x equals 10. Remember, these are or statements. Or subtract 4. X equals negative 18. And you can double check and you see both of those solutions solve our equation. Next problem. Alright, going to number 10. It says solve each equation and check for extraneous solutions. Since this one, the absolute value is already isolated on one side of the equation, and you notice the variable outside of the absolute value sign, this is a time to check for extraneous solutions. Again, solutions that would work, that we can work, but actually don't solve the problem. So since it's already isolated, we can go ahead and have a positive solution set. So x minus 1 equals 5x plus 10. And a negative solution set, x minus 1 equals negative 5x minus 10. So let's work the positive one first. So first thing we're going to do is, it really doesn't matter how, but let's subtract x to each side. So I'm going to get negative 1 equals negative 6x. Negative 1 is going to equal 4x plus 10. I'm going to subtract 10 to each side. So I'm going to get 4x equals negative 11. So x is going to equal negative 11 over 4. Okay, let's look at the next solution set. Okay, I'm going to add 5x to each side. Again, I like to keep my variables positive if I can. So I'm going to get 6x minus 1 equals negative 10. So now I'm going to add 1 to each side. So I'm going to get 6x equals negative 9. So I'm going to divide each side by 6. So x is going to equal negative 9 over 6, which is negative 3 over 2. So now what we've got to do is plug these values back into the original equation and see if they both still work. So we'll start with the first one on the left. We just got to plug negative 11 forced back into the equation. So the absolute value of a negative 11 over 4 minus 1 equals 5. Now x value is negative 11 over 4 plus 10. Okay, so let's look at this real quick. So negative 11 over 4 minus 1 is the same thing as negative 11 over 4 minus 4 over 4. Okay, so that's going to be the absolute value of negative 15 over 4. Okay, absolute value is going to change it, so the left side is going to be 15 over 4. The right side was 5x, sorry, I wrote that wrong, plus 10. So 5 times negative 11 over 4 is negative 55 over 4. Okay, plus 10 plus 10 would be the same thing as plus 40 over 4. So my right side is going to be negative 15 over 4. Okay, so that's the kicker. This cannot be negative. So this solution on the left is extraneous. Okay, now let's look at the equation on the right. Let's plug it back in. The absolute value of x, which is 3 over 2 minus 1, equals 5 times negative 3 over 2 plus 10. So the left side is going to be negative 3 over 2 minus 2 over 2. So that is going to be the absolute value of negative 5 over 2, which would just be 5 over 2. Alright, let's go check the right side of the equation. Distribute the 5, so I'm going to have negative 15 over 2 plus 10. Well, that would be the same thing as 20 over the 2. So that's going to end up being 5 over 2. 5 over 2. So that one checks. So this is the only solution for the problem. X equals negative 3 over 2. Okay, that was number 10. Going on to number 13 to get more work at it. Okay, so here we go. 13. The absolute value of 2y minus 4 equals 12. Okay, the absolute value is already isolated on its own. So we can go ahead and write a positive solution set. 2y minus 4 equals 12. And we can have a negative solution set. 2y minus 4 equals negative 12. So we're going to add 4 to each side. I'm going to get 2y equals 16. Divide each side by 2. I get y equals 8. And I can pretty easily from here check that to make sure it works. 2 times 8 is 16. So you can follow along with me. 2 times 8 is 16, minus 4 is 12. Okay, easy stuff. Absolute value of positive 12 is 12. All right, let's work the or side. Add 4 to each side. So I get 2y equals negative 8. Divide each side by 2. Y equals negative 4. So I can check that one as well. And it's going to work. And again, the easy thing on this is all you really have to do is if there is no variable outside the absolute value signs, they're probably going to work. Okay, going on to the next problem. Number 16. The instructions say, solve each inequality and graph the solution. So 16 is this. The absolute value of x plus 3 is greater than 9. Remember, that's going to make it an or statement. So the the absolute value is already on one side of the equation. So we're going to set up a positive solution and a negative solution. Okay, the positive solution set is nothing more than x plus 3 is greater than 9. The negative solution set, remember, we're going to have to go with negative, so we're flipping the inequality. So it would be x plus 3 is less than negative 9. Let's solve the positive solution set first. So we're going to subtract 3. So our solution will be x is greater than 6. Remember, this is an or statement because it's less than. I mean, since it's greater than right there. So over here, subtract 3 just like we did before. So I'm going to get x is less than negative 12. So let's put a number line down. I'll mark 0, I'll mark 6, and I'll mark negative 12. X is greater than 6, so a hollow circle on 6, greater goes to the right. The other one right here, x is less than negative 12, hollow circle on 12, no equal signs, going to the left because of less than. Number 19, absolute value of 2x plus 1 greater than or equal to negative 9. Okay? Let's just check it out. There's some things I could tell you beforehand, but we'll just work it out. Since it's already set, we'll make a positive solution set, 2x plus 1 greater than or equal to negative 9. And we need a negative solution set, which would be 2x plus 1 less than or equal to positive 9. Subtract 1 to each side. I'm going to get 2x greater than or equal to negative 10. Divide each side by 2. X is greater than or equal to negative 5. We have our OR statement. Subtract 1. So I'm going to get 2x is less than or equal to 8. Divide each side by 2. I'm going to get x is less than or equal to 4. So chart that on a number bar. Negative 5 and positive 4. So x is greater than or equal to negative 5. So that's a solid circle on negative 5 going to the right. X is less than or equal to 4. Solid circle on 4 going to the left. So what do you notice? I got arrows going both ways, so this one would be all real numbers. And scroll back to the top, and since here's the kicker, here's where you can kind of tell. Since that's a negative number, and the absolute value of anything is positive, we should have been able to tell right off the bat all real numbers would have worked, and we wouldn't even have to actually work this equation at all. Okay? All right, moving on to number 28. All right, we're given a compound inequality. 1.3 is less than or equal to 8, less than or equal to 1.5. The question says, write this as an absolute value inequality. Well, what did we tell you to do? We had to find the average and we had to find the tolerance. The average is the sum of the maximum and the minimum divided by 2. So that's 1.5 plus 1.3 over 2. That's going to be 2.8 over 2, which is going to be 1.4. The tolerance is the difference of the maximum and the minimum. So it's going to be 0.2 over 2. So it's just going to be 0.1. How we write this absolute value inequality is like this. Whatever we're looking for, which is our h, minus the average, is less than or equal to the tolerance. So to write this one, it's pretty simple. Absolute value sign h minus, our average was 1.4, close it, and our tolerance was 0.1. So there's your absolute inequality for number 28. Okay, number 31. Same type of question. It's going to give us a compound inequality. 50 is less than or equal to b, less than or equal to 55. Okay, our average is the maximum plus the minimum divided by 2, which is going to be 52.5. The tolerance is the difference. Maximum minus the minimum divided by 2. So that's going to be 2.5. So my absolute value set is nothing more than absolute value of our variable b minus the average, 52.5, less than or equal to the tolerance, which is 2.5. So there we have our absolute value inequality. The absolute value of b minus 52.5, less than or equal to 2.5. Going on, number 34. Solve each equation. I have a negative sign, absolute value of 4 minus 8b equals 12. Okay, I got to get rid of the negative sign. So what am I going to do? I'm going to multiply each side by -1. Okay, so now I'm going to get the absolute value of 4 minus 8b equals -12. What did I tell you just a minute ago about a negative solution to an absolute value question? It cannot happen. So there's no solution that an absolute value number is going to be negative. So there is no solution. So sometimes it really helps to just inspect the problem before we try to solve it. Okay, going on to number 40. All right, absolute value of 3x. Check that. 2 times the absolute value of 3x minus 7 equals 10x minus 8. Okay, first thing we want to do is we want to get the absolute value by itself, so we're going to divide by 2 across the board. So I'm going to have the absolute value of 3x minus 7 equals 5x minus 4. Okay, I've got the absolute value isolated, so let's have a positive solution set. So I have 3x minus 7 equals 5x minus 4. I have a negative solution set, divided by an OR statement. 3x minus 7 equals negative 5x plus 4. So we just got to go through our steps. I'm going to subtract 3x to each side in this look. So I'm going to get negative 7 equals 2x minus 4. Add 4 to each side. Remember, I'm trying to get the variable by itself. So I'm going to get 2x equals negative 3. Divide each side by 2. So I'm going to get x equals negative 3 over 2. All right. Or, let's check the next side. I'm going to add 5x to each side. I'm going to get 8x minus 7 equals 4. I'm going to add 7 to each side. So I'm going to get 8x equals 11. Divide each side by 8. I'm going to get x equals 11 over 8. And really quickly, you can plug these in, and what you're going to find out is when you plug this solution set in, this is going to become a negative number. Okay, so it's not going to work. That's not going to satisfy our equation. Okay, when you plug in 11 over 8, it is going to work. Okay, it is going to work. So we can do that one. That's our solution. This one was extraneous. So no solution. Now we're going to go to 1.6 review, page 42, and we're going to do numbers 9, 13, 16, and 19. After you do all this, you should be really ready for the test. So review these sections, do these problems, and you should be okay, plus the review sheet we gave you. All right, a jar contains 30 red marbles. So there's 30 red marbles. Okay. It contains 50 blue marbles and 20 white marbles for a total sample of 100 marbles. You pick one marble from the jar at random. Find the theoretical probability. Find the probability it is red or blue. All right. So theoretically, it's what meets our criteria over the total number. So red, there's 30 that meet that criteria, or blue, there's 50 that meet that criteria. You should just add them because it's an OR statement. over the total number of possible solutions, which would be 100. So the answer would be 80 over 100, which could be written as 4 over 5, or 0.8, or 80%. Easy stuff. Number 13. Okay, number 13. A bag contains 36 red, 48 green, 22 yellow, we're getting fancy now, and 19 purple blocks. You pick one block at random, find the theoretical probability. For 13, it's asking for the probability of green or yellow. So let's add these up real quick. All right, 6 plus 8 is 14, 15, 16, 25. 5, 6, 7, 8, 9, 10. So there's 125 total. So the probability is the number that meet our criteria over n, the total number. So green or yellow. Green was 48, and yellow is 22, and the total number is 125. So our answer is going to be 70 over 125. So we can probably factor out a 5. So we're going to get 14 over 25, which would give us a decimal of 0.56, or 56%. So 4 over 25, 14 over 25, 0.56 or 56%. All right, next example, number 16. For each situation, find the sample space and the theoretical probability that a child will naturally place their left thumb on top. All right, the father, remember our diagram here. The father and the mother. The father has recessive genes, the little g's. Okay. And the mother has both dominant genes. So each box is going to be capital G, little g, capital G, little g, capital G, little g, capital G, little g. So what's the sample space? Well, there's 4 sample spaces. So the sample space is 4. All right, and then find the sample space and the probability that the child will naturally place the left thumb on top, which we learned was the dominant. So theoretically, this one will be a 4 over 4. He'll have a 1 or 100% chance. Okay, does that make sense since the capital G was in each box? All right, last one, number 19. We worked one just like this in class. Suppose a dart lands at random on the dartboard shown as right. Okay, so they show on a dartboard that has 1, 2, 3, 4 rings. Each ring is 1.5 inches. Okay, the first one is worth 20, the second one's worth 10, the next one's worth 5, the last one's worth 20. So each ring is 1.5 inches. Obviously, this is not to scale. So we need to find that we'll score at least 10 points. So where will we score at least 10 points? Inside this circle that says 10 and that circle that says 20. So that distance right there would be 1.5 times 2. So the radius of that one is 3. So we want to find the probability of at least 10 points. Well, all that is going to be the area of everything that gives us 10 or more points over the area of the sample. Okay, So the area of a circle inside 10 is pi r squared. The radius in that example is 3, so it would be pi 3 squared, which would be 9 pi. Okay, now we got to find the sample set. Well, we go 1, 2, 3, 4 rings we cross. Each ring is 1.5, so 4 times 1.5 is 6. So the area of the entire surface is still pi r squared, but my radius here is 6, so it's going to be 6 squared. So it's going to be 36 pi. Okay? So now we can just cancel and reduce. The pi's are going to cancel. So it's just going to be 9 over 36, which is just going to be 1 over 4. So our answer is 1/4, 0.25, or 25%. That's the probability it's going to hit somewhere in the yellow. Okay, that's the review. If you can do these, you should be just fine for the test. Keep looking over your problems. If you have any questions, feel free to email me or just rewatch this video.